Well, good afternoon, everyone, and thank you for joining Geoscience BC's Minerals webinar. I'm Gavin C. Derome, the President and CEO of Geoscience BC. Now, please welcome our board chair, Lana Eagle, for her opening remarks.
Hi, everyone. It's so good to see you all, and I'm glad that you're able to make time in your busy schedule to be with us today. I'd like to first start with a land acknowledgement that Geoscience BC is located and works on the traditional territories of the Squamish, the Musqueam, and the Tsleil-Waututh people. And we're calling in from all parts of BC, and so I know that wherever we work and play, we are located in a traditional territory of a First Nation. I just want to thank everyone for being here, as I've already said, but I also want to thank everyone who has been a past volunteer or a current volunteer, because really in today's world of how organizations work, we couldn't get by without our volunteers. So we do thank you for that. And thank you for your time and for making this the organization that we are. That said, we've been operating most recently in a little bit of a care and maintenance mode, only because things are changing. Times have changed. The funding isn't as readily available as it used to be in days gone by. And so with that, we are looking to what our future might be like and how we can adapt and how we can change. But I'll talk more about that at the end of our webinar. In the meantime, I'll turn it back to Gavin for his opening remarks. Thanks, Gavin.
Excellent. Thank you, Lana, for both your leadership and for setting the stage for today's webinar. So before we begin, note that we'll have time for the questions after the two presentations. So please feel free to enter your questions into the chat or use the raised hand feature if you'd like to speak. Your cameras and microphones are switched off to avoid the background noise. And you may turn them on when invited to do so. Please also note that today's webinar is being recorded, and a copy of the recording along with the presentations will be shared with all the participants. So the main presentation will be delivered by Joel Langan from Centerra Gold, who will speak to the Trek and Search Phase 1 projects that he was directly involved in. Krista Pellet will introduce Joel later in the webinar. A key reason of Geoscience BC's success has been its collaboration model and its strong network of subject matter experts and the volunteers, as Lana mentioned earlier, committed to our rigorous and peer-reviewed and publicly available science. And I would like to just take a minute to recognize several volunteers and leaders of Geoscience BC, including the founder and first board chair, John Thompson, and subsequent board chairs, Mike Cathro, Stephanie Killam, Donna Phillips, and at present, Lana Eagle. And on behalf of the board, I especially wish to recognize and celebrate the life and highlight the contributions of Mike Cathro, who recently did pass away on April 22nd after a courageous battle with prostate cancer. Mike, many folks know, was a respected geoscientist, a leader, longtime contributor to responsible mineral development in British Columbia. His work and his leadership helped shape Geoscience BC's direction, and his legacy continues to be a positive influence on the organization and the broader geoscience community. Mike was a good man, and we will always remember him. I would now like to thank TriPoint Geological Services Limited for sponsoring today's Minerals webinar, and to introduce Darcy Biss, who will provide the first presentation. Darcy is part of the younger, business-savvy, technically strong next generation of Canadian geoscientists. Darcy is based in Victoria, but originally from northern British Columbia. He spent nearly 2 decades contributing to mineral exploration projects across Canada and the United States, and through TriPoint Geological Services continues to support practical, collaborative, and innovative exploration. I'll now pass over to Darcy for his presentation. Thank you.
Thanks, Gavin. Let me just turn on my slide here. You can see that okay. Yeah, so My name is Darcy Viss. I'll be giving a presentation today on the critical role of Geoscience BC from early careers to AI integration and everything in between. It's a large topic, and I have exactly 9 minutes to give it, so it'll be quite brief. If anybody wants to discuss any of these topics further, feel free to email me at any time. My email address is there on the screen, and you can always just Google TriPoint and find it there as well. So there's a quick agenda here. We're going to start with who I am, my personal geoscience BC history and experience, how Geoscience BC influenced the company that I helped build and currently own, which is TriPoint, current projects that we're working on, future developments, and the need for Geoscience BC. So about 20 minutes ago, I realized that I didn't have the slide in here, so I quickly whipped it off because I think it's important for the story itself. So I've been a geologist for many years. I got my first job with Geoscience BC, which we'll discuss shortly, but I'm currently the president and owner of TriPoint Geological Services, a geological consulting firm that works primarily here in BC. I'm also a board member of AME BC. I'm a member of the EGBC Natural Hazards and Natural Resources Advisory Group. I'm a member of the BCGS Technical Liaison Committee. I own my own sort of project generation company, which is it was a hobby and now it's turning into not a hobby. I'm also the VP exploration for a couple of currently private companies, Golden Access and Tenova. I'm also a director at Invicta Metals, which is a group that's looking at how we can improve Indigenous and First Nations engagement and participation in mineral exploration. So in essence, I'm just an all-around exploration guy who has been working in the industry for almost 20 years now. And yeah, I do way too many things, apparently. So a bit of introspection there. So my first job was with Geoscience BC and SFU. It really launched my career into geoscience. So my first job was in 2008. At the time, I was 16 years old. I was working in a hydraulic shop, and a family friend of ours, Martin Gertzma, who is the geomorphologist for the Prince George region, he asked my dad if any of his sons wanted to go and dig holes in the forest, because they had needed a field assistant for their work. And so I liked rocks, so I said, yeah, I'll come and do it. And so that sort of launched a 2-week field stint with Geoscience BC and Simon Fraser University in 2008. So I bagged dirt with Trevor Rabb, who some of you may know. He's now a partner at Equity Exploration. And I enjoyed it so much that in 2009, I reached back out to Brent Ward, who was running that program, and said, hey, do you guys have any work? I really enjoyed it. And so I went back out and worked with Brent, Dave Sacco, who's subsequently done a significant amount of work with Geoscience BC and is with Palmer. And I've met many other people through that process. So the key findings that I had at the time was I love being outside, and I wanted to make a career out of being outside if possible. Wearing hiking boots was fantastic. I really enjoy rocks, something that I knew most of my life, but it really solidified that. And I was shocked that people would actually pay you to go wander through the forest and look at dirt and rocks and things. So that really, really reaffirmed that decision to go into there. Here you can see a couple of photos. The first one there is from 2008 when I was 16 years old. It was the last field day. I was wearing quick dry stuff, and I now that day I didn't want to wear my stinky pants, so I wore my jeans. And then down below there is me digging a big hole in 2009. So that really sent me on a career path of geoscience and a love for public geoscience itself and the methodology. And I had a really rich career. And in 2019, we started TriPoint Geological Services, which provides consulting to a large number of different clients and groups throughout Canada. And really, when we started the company, it fell onto my shoulders to come up with a lot of the procedures that we were using. And so it's one thing to show people how to do things in the field or know how to do things. It's a whole other thing when you're actually writing company-wide procedures. And Geoscience BC really came to the rescue. A lot of their reporting was done really well, and they had really clear methodologies. And so here's some of the ones that we've utilized as a company. Soil sampling methods, particularly the ones that were done at Quinnica and Mount Milligan, were used with different soil horizons. Till sampling techniques from a number of projects that Geoscience BC did. Biogeochemistry, some fundamental ones there by Heberlein and Dunn. Geochemical vectoring, particularly the porphyry vectoring that Bizarre et al. Did in the Toodoggone is used heavily by the company. And currently, more recently, O2 CO2 soil gas methodologies. We actually are working with Ray right now. We're doing a survey, and he actually showed our team last week how to utilize that technology. So we're building and definitely standing on the shoulders of giants, I think, is a key aspect here. Another aspect of Geoscience BC that we use on the regular is all the data sets. We rely heavily on the regional geochemical surveys, of which Geoscience BC participated in and added value to. The regional geophysical data sets, which you can see here is shows the Quest data, and the regional geology. It's fundamental and foundational for what we do as a company every day. So a couple of really brief projects that we're doing in the region is the main one is the Fishpot project, which is in the Trek area, which Joel will be discussing shortly. We use some of the geoscience data to really have our fundamental ideas about this, as well as historical data that was collected. Golden Access is in the process of doing their IPO. We've recently done geophysics, and we're looking at doing more geophysics and hopefully a drill program in the near future. And those targets were largely generated and supported by the Trek data. A couple of my own projects. The Carp Lake is a rare earth project that's really early stage. It's my own personal project. We're looking for rare earths within the Wolverine Metamorphic Complex, which is overlain by the Quest data. So the Quest data and the till sampling and the geophysics has been really helpful in that. There's still not a large guarantee of success there. We're poking away at it. My main thing is if we do find something there, it would be groundbreaking. It would open up that whole region. So stay tuned for that. And then also looking at regional targets in which to utilize some of these new techniques that we have. We're looking at different magnetic anomalies. I have marked there the Eden as well, which is a tungsten target that we're exploring, which is largely till covered as well. So the data continues to generate and support exploration in the region beyond just its initial collection. Other things that we're doing as a company, we're continuing to build data sets to test these methods and theories and things, especially the vectoring. So we're increasing our geochemical data sets and applying things like the MPIX, which was developed by Bizarre et al., and refine that. We're taking a lot of the applied techniques that were developed by Geoscience BC, and we are refining them, utilizing them, tweaking them to improve our ability to explore. And we're also starting to utilize more and more machine learning, which many people know as AI. And the geoscience data sets are incredibly important for that, which I'll discuss. Data coverage for AI is its Achilles heel. So data from Geoscience BC and the large regional data sets help significantly with that process. The need for Geoscience BC, collaboration between industry, government, and academia is incredibly important, and it's a beautiful thing I have there. Having a group that can facilitate that and really play to the strengths of each group, and including government there is also First Nations government. It works really well. And so these large regional data sets continue to aid us in our traditional methodologies, as well as forward-looking AI supported prospectivity. And the development of these new techniques really helps us look better at what we already have and find these areas where things might not be as clear or as traditional. And it's really the spark which starts our continued development of new and novel techniques. And also the cross-generational working. I call it cross-generational. I think it's more just different levels of experience of geologists working together on projects is always going to be better for the transfer of knowledge. So a lot of the Geoscience BC work and surveys is a lot of different geologists with different experience levels. So a lot of information has been transferred from generation to generation through these surveys, which I don't think can be understated. Here I am with my rock in 2026, so a bit of a full circle moment. This is my project that I'm working on Vancouver Island. I also have a lot of references here that people can look up after of key things. It's a very small amount of things. I really recommend people look at the Geoscience BC website to find more information, because there's a lot there. There's a lot of good wisdom and knowledge. All right, we did it. I was 10 minutes, so I apologize, Rich and Gavin, but thanks.
Great. Thanks, Darcy. It's always great to hear about the value of Geoscience BC data and projects to mineral exploration and discoveries today. Hi, everyone. My name is Krista Pellet. In a former life, I was VP Minerals at Geoscience BC and am now with Purple Rock. And I'm very pleased to introduce our key speaker, Joel Angan, to you today. Joel will be speaking on boosting BC critical and strategic mineral exploration, discovery, and development, legacy Trek and Search Phase 1 projects. Back in 2013, the Trek project marked a shift in Geoscience BC's major project development. Our previous Quest series of projects were mainly focused on regional geophysics and geochemical surveys first, and the Trek and Search regional magnetic surveys started to continue in that tradition by adding new regional geophysics over more than 30,000 square kilometers in central British Columbia. But importantly, with Trek, our Minerals Technical Advisory Committee wanted to include a mapping component from the outset of the project instead of planning it later on after we'd already flown the regional geophysical surveys. And we were very pleased to be able to work with MDRU on that component, and then again with MDRU and BCGS staff on extracting value from the Search Magnetic Survey over the Skeena Arch a couple years later. I'd be remiss if I didn't note that these two projects, Trek and Search 1, were championed by two previous Geoscience BC Vice President of Minerals, Kirsty Simpson and Bruce Madu. And so I'm very much looking forward to hearing on Joel's insights on the legacy of these two public geoscience projects. Now, a little bit about Joel. Joel earned a BSc from Earth Sciences from the University of Victoria in 2009, followed by an MSc from the University of Waterloo in 2013. He worked as a research associate at the Mineral Deposit Research Unit from 2014 to 2018, focused on utilizing regional Geoscience BC aeromag datasets and targeted field mapping to unravel the geological framework and aid in mineral exploration in central British Columbia. This included components of the Trek and Search 1 projects that we'll be talking about today. Currently, Joel is Manager Geosciences with Centerra Gold, where he contributes to project evaluations and active exploration programs across Canada. And with that, I'll turn it over to Joel.
Great, thanks, Krista. Yeah, I felt honored to be asked to give this presentation today. I was thinking about all of the exceptional quality research that Geoscience BC has funded. So being asked to present today felt like I was I don't know, maybe undergunned, but hopefully by the end of the presentation, I'll have something valuable to say. If I can get it to move. There we go. All right, so just in terms of an outline, we're going to be talking about the highlights from the Trek geology and integration and extracting geological value from Search Phase 1 projects. The links should be available to you for those two projects on the Geoscience BC website. And then from there, take those observations into our late Cretaceous and Eocene metallogenic setting and onto a conclusion. On the right here, we're just looking at the major regional geophysical surveys that that Geoscience BC is so well known for. The Trek project is right here, and the Search project is right here. I also want to take the opportunity now to give credit to my co-authors on these two projects. So that would be for Trek, Craig Hart, Mana Rahimi, and Rachel Kim, who were at MDRU with me, and Jim Logan and Liz Westberg, who were mapping in the field with me. And on the Search project, that would be, again, Craig Hart and Mana Rahimi, and Joanne Nelson with the BC Geological Survey. All right, so quick introduction to the Trek project. We heard a little bit of this already from Krista, but the location that we're looking at here is basically bounded to the west by the Tweedsmuir Provincial Park and extends east towards Grinnell, and from Vanderhoof in the north down to Anaheim Lake in the south. Part of the initiative for this project was the discovery of the Blackwater epithermal gold-silver project, which is located right here near the center of the project. So a little bit funny that in the critical minerals session, we have a gold exploration geologist presenting about a project that was prompted by a gold discovery. But I think by the end of this presentation, you'll see why it's not just a gold story here, really. It's critical minerals as well. This is an area that is notoriously difficult to explore. You can see what the terrain looks like. It's relatively flat, mostly till covered. There's not much bedrock exposure. So the idea was to start this multidisciplinary campaign, including the new aeromagnetic data, new surface geochemistry, and the updated geological map component, which is what I was involved in. And here is our final map product. I have to say, it's a bit of an unsatisfying map pattern, but that is the product of this area having effectively the same paleo surface environment since the Cretaceous. So we have relatively flat, isolated volcanic centers, which then are partially eroded, and another volcanic package deposited on top with erosional windows, and another volcanic package. So you don't get well-developed stratigraphic sections anywhere. Everything is relatively flat-lying since the Cretaceous. And this is the magnetic data that it was partially based on, with the combination of utilizing previous mapping and our targeted mapping in the field. What I think will be a useful exercise is to walk through some of those flat-lying volcanic packages and highlight their magnetic textures. So starting with the Chilcotin group, which is this tan color in here, it mostly covers flat-lying areas and it's thickest in paleo drainages. And it actually has this distinctive mottled volcanic texture or magnetic texture, which you can see in here. And it was actually Randy Ankin who established that the Chilcotin group has a uniquely high remnant magnetic component, and it includes both normal and reverse polarity flows. So in areas where you have dominantly normal polarity flows, it'll show up as a magnetic high. Where you have dominantly reverse polarity flows, it shows up as a magnetic low. And the variable thicknesses of those flows is what gives us this irregular model pattern. And that's mostly Miocene volcanic package. Beneath that, we have the Endako group, which is Eocene to Oligocene basalt to andesite package. And this forms a series of very strongly magnetic features. There's one right here, kind of the shape of an elephant's head. There's another one here and another one here. And what we see in the field is that the Endako group has the strongest magnetic susceptibility of all of the map units we identified in the field. Directly underneath the Endako group is the Utsulate group. You can see it in this sort of orange-brown here. It's not that thick in this area. It's much thicker down here to the southeast. And that also has a unique magnetic fabric, which is this north-south striped pattern. And Esther Bourdet recognized that is related to a series of normal faults, which partially control the distribution of the rhyolite package. And that is about as far as you can take the distinctive magnetic textures of our superficial or our subhorizontal volcanic packages. And unfortunately, the late Cretaceous Casalca group, which is right here and is the host to the Blackwater deposit, which was a primary target of interest when we started this project, doesn't have a unique magnetic texture. But it forms these isolated packages of trachyandesite and rhyolite. You get one here, another one here around the Cabin Lake Pluton, and a little bit in here just on the north side of the Utz Lake Reservoir. What we're going to do now, we're not, I should mention this, all these greens are the Jurassic volcanic rocks in this area, but in this area, they don't seem to have very much in terms of mineral potential. It's really the late Cretaceous and Eocene volcanic packages that are the targets here and the associated intrusions. So we're going to dive a little bit deeper into those, starting with the Casalca group. We're looking at here just the alkali versus silica diagram. And what we see is the components of this magmatic system that made it to surface are dominantly trachyandesite, so slightly alkaline, intermediate volcanic rocks, and then these high silica rhyolites. And we have this notable gap in the middle. So we have a form of bimodal distribution here. If we just dig a little deeper into the trachyandesites to start, looking at their rare earth element profile here, we see this listric pattern where our mid and heavy rare earths are somewhat depleted compared to light rare earths. And that is indicative of hornblende being a fractionating phase. And these do not have a europium anomaly, so the origin of this magma did not have plagioclase as a fractionating phase. So those two observations together indicate that this formed in a high pressure and high water content environment. Now looking at the rhyolites, they have the same listric profile, but with a pronounced europium anomaly. So it suggests that we have the same magma as a source, which underwent a subsequent fractionation event where plagioclase was stable. And in fact, just to get this high silica content in a volcanic rock, you do need to have an upper crustal fractionation event. Right, now if we take that back to our map and look at where there's mineralization associated with it, of course, the Blackwater deposit is the most famous one in this area, but there are additional epithermal flow dome hosted deposits. It's kind of, I use the term Blackwater type because it's a bit of a unique style of epithermal mineralization that we see here with these large low-grade flow dome hosted systems. There's what looks to be similar style of mineralization up at Holy Cross, and at Capoose, rather than being flow domes, it's a series of rhyolite sills. There's also polymetallic and potentially porphyry mineralization up at the Cabin target in the north. And at 3Ts, the mineralization seems mostly to be more typical vein-hosted epithermal mineralization, although apparently they have identified a rhyolite flow dome there with some mineralization. So we'll see what that develops into. Now, moving on to our Eocene geochemistry, we have the Utz Lake group, which is dominantly felsic, again, slightly alkaline, trachyte to rhyolite. We don't have the clear gap that we see with the Casalca group, but otherwise relatively similar geochemistry. And then we have the Indaco group, which is the mafic component that's sitting on top of the Utz Lake group in this area. And I realized this morning that this diagram actually has the symbols flipped. So here, Endako group is hollow, here Endako group is solid. So I'm going to have to fix that before I distribute this presentation any further. But the Endako group has this E-Morb to continental arc contamination signature. And I really like this diagram because it basically shows the entire volcanic history of the Chaco Plateau in one diagram. So our Jurassic volcanic rocks are sitting here in the oceanic arc environment. Our Cretaceous volcanic rocks are sitting here in the continental arc environment. The Utsulate group has almost the same signature. And then the Endako group has this E-Morb to contamination trend. And our two Chilcotin group samples are again in the mantle array, but towards ocean island basalt or interplate environment. Now, taking that back to the map again and looking at where we have Eocene mineralization, Darcy mentioned the Fishpot prospect, which is right here. We have a whole series of other epithermal targets associated with the Utsulate group in the southwest, several associated with Utsulate group in the southeast, northwest, and we have at least one target here at 2 times Fred, where we have epithermal mineralization conclusively cross-cutting the Endako group. And we have the Chu Molly prospect right in the middle. Now, we're going to look at the search map area. I don't want to spend too much time on this, but just focus on the recognition that in this area, we do have exceptionally well exposed section of Stikine terrain, starting with the Mississippian to Permian basement in the west, continuing right up through the Triassic and Jurassic to Saddle Hill Formation, Jurassic rocks here. We cross a normal fault, and then we go back to Triassic and up through the Jurassic stratigraphy again. In the north, we actually have at Ashman Ridge here, one of the type sections of the top of the Hazelton group up into Bowser Lake group. And despite having this exceptional exposure of Stikine Triassic to Jurassic stratigraphy, we don't see the same level of targets of that age that we see elsewhere in Stikine terrain. But what we do see is once again late Cretaceous mineralization. We don't have a lot of late Cretaceous volcanics in this area, but where we have late Cretaceous intrusions, we get porphyry prospects. So we have the Davidson Molly tungsten deposit here on Hudson's Bay Mountain, the Louise Lake copper gold molly porphyry here, and the Hidden Valley prospect in the north, the Hobbs prospect, which was drilled by Eastfield Resources, I think around 2015 or 2016. The Sunsets Creek target here, Tatsy, and the most recent addition would be the Kendall prospect, which is recently confirmed as a copper molly system by Red Canyon Resources. And they have dated this Kendall intrusion. They have uranium, lead, zircon, and a rhenium osmium age, and they're both 93 Ma. This is another late Cretaceous porphyry system in this area. And where we have Eocene intrusions, we also get porphyry, in this case, porphyry molly at Serb Creek. And this has advanced argillic alteration at Limonite Creek associated with another Eocene Nanika Suite intrusion. Okay, now taking all of that information and applying it to our metallogenic environment for the late Cretaceous and the Eocene. Here we're just looking at a simplified tectonic map of BC, ancestral North America in gray, the shelf and slope environment in blue, and then on that we have in red our oceanic remnants, so that's Slide Mountain and Cache Creek, And our terrains, we have Quesnel terrain in the east, Sikkim terrain right in the middle here, and then the insular terrains off to the west. And overprinted on top of that, this was all amalgamated at least by the end of the Jurassic. And on top of that, we have our post-accretionary overlap sedimentary rocks in tan, volcanic rocks in this pale green through here, and post-accretionary intrusions in pink, which includes the massive Coast Plutonic complex in through here, but also all of these scattered intrusions all the way across the Cordillera. So the question that was first presented to me after we were well on our way through the Trek project, Craig was asking, so why is there all this magmatism and mineralization east of the active continental arc defined by the Coast Plutonic complex? And there's a few other things that we should consider along with that. This Coast Plutonic complex is very wide, 200 kilometers wide in some places, but within that, the active arc at any given time was much narrower. So I always come back to this reference from George Garrels, where he plotted all of the ages of intrusions where the actual sample was collected in the Coast Plutonic complex against the distance from the coast shear zone. So here we're looking at east-west distance, and here we're looking at age. And ignoring what's going on before about 120, where it's a little bit more complicated, let's say 120 or 110, the Coast Plutonic complex is pretty clearly a single arc that was about 50 kilometers wide. And that arc axis was migrating towards the east fairly substantially, somewhere around 2 kilometers per million year between 110 and let's say 70 MA. So this reflects the eastward migration of the active arc when this entire origin was in compression. And at the same time, we have major shortening events in the Skeena Fold and Thrust Belt and Rocky Mountain Fold and Thrust Belt. So in terms of a metallogenic setting, what we came up with is this, which is really just an application of the work done by Jeremy Richards. He defined this environment based, he called it a post-arc porphyry compression, but we would call it a behind-arc porphyry environment because we still have the active arc, which was the Coast Plutonic complex. So I'll try and walk through this diagram. In the standard arc environment here, we have our subducting ocean crust, which releases fluids into the asthenosphere, causes partial melting, and that magma then rises up and ponds at the base of the crust here and forms a mash zone. So melting, assimilation, homogenization, and storage. And that then produces our arc magmas, which come to the near surface environment where they can produce porphyry and epithermal and related systems. But if you take an old mash zone, like we would have underneath Stikine terrain or any other arc terrain, and then put it into compression, you force those rocks down and you can cause them to go into partial melting and produce what also looks like an arc magma. So just looking at this bottom diagram here, we have pressure on the y-axis, temperature on the x-axis. Here's our geothermal gradient. Here would be the solidus of dry rocks and the solidus of rocks that have hydrous phases in them, which reduces your melting temperature. So if you take rocks that are sitting here on the geothermal gradient, happily not melting, and you force them down, initially you don't get any melt forming, but then as those gradually re-equilibrate to the geothermal gradient, you produce low-degree partial melts. And this can happen over a broad area and takes quite a long time to heat up that amount of rock. So what we end up with is low-degree partial melts as I said, over a wide area in a long time, what looks like something like 30 million years in the Cordillera. So from somewhere around 95 to about 65 MA. And as I said, this can happen where we're melting a former mash zone, but it could also happen where we're melting continental crust or even sedimentary rocks, which could produce an S-type magma. Now, take that again back to our map of BC here. What we see is a variability in magmas and the associated deposits based on what melted. So mostly underneath our old volcanic arcs, we are melting mash zones. So we produce what looks like an arc magma and capable of producing copper gold porphyry systems and epithermal systems. And we see those all through, particularly all through Stikine terrain. But if we are melting our continental crust, like we would be doing up in the Tombstone Belt, you can form reduced intrusions, and those would be associated with porphyry, tin, tungsten, moly, reduced intrusions, and tungsten skarns, like the Mactung deposit. And one last point to make here is that some of these systems can be very large. So Blackwater, which is what we started out looking at, is just over 11 million ounces of gold. New Prosperity is just over 1 billion tons at 0.24 copper and 0.41 gold. Mactung is really in a class of its own in terms of grade and size for tungsten deposits. And the Valley deposit is rewriting the textbook on reduced intrusion-related gold systems. One that was actually new to me pretty recently is the Silvertip. The silver lead zinc deposit is also the same age, it's about 70 MA. Okay, now moving to the early Eocene tectonic setting. Again, we still have the Coast Plutonic Complex as a pretty well-defined arc axis, right up to 50 MA when it shuts off. But instead of being in compression behind the Coast Plutonic Complex, this is a period of extension. We have widespread normal faulting and exhumation of core complexes across BC. So in this environment, we still have our active arc, but the Cordillera behind the arc has gone into extension, and we are effectively doing the reverse. This time we're taking rocks that are at depth here and bringing them up towards surface, so they immediately go into the melting environment, and this produces higher degree partial melts over a shorter time period, sort of like what we see with the Utsa Lake group. But again, if we're melting a former mash zone, we can still produce what looks like an arc magma. And looking at our map, we see the deposits associated with that magmatic event. We have more copper moly, but also some copper gold deposits, quite a few epithermal deposits, and in the case of Stardust, we have a skarn. And finally, just one comment on the late Eocene after shutdown of the arc. So there's a transition that we can see in the Coast Plutonic Complex where magmatism ends right at 50. We have a transition then to a strike slip boundary here. Our subducting slab continues to sink, and we get ingress of hot asthenospheric mantle, which causes this EMORB-looking melt in the asthenosphere and variable contamination of that as it comes up to the surface. That melt, because it doesn't have a source of water in the melting environment, is relatively low water content, but high temperature. So it can only form the true end-member low sulfidation epithermal mineralization. And we see that one example in the Trek area with the 2x Fred project. It's not really well recognized elsewhere in BC, but the Republic District in Washington is the same age, around 45 MA, and hosted in similar rocks, and has produced just over 4 million ounces of gold. So in conclusion, both the Cretaceous and Eocene magmatic systems in BC are highly prospective for critical minerals and gold, both formed through melting of subduction modified lithosphere behind the active arc, and Cretaceous deposits formed during lithospheric thickening, and Eocene systems formed during lithospheric thinning. Thank you.
Fabulous, Joel. Excellent. Thank you very much for that. Folks, we now have time for questions to Joel and perhaps to Darcy as well. And just a reminder, if you could raise your hand, and I'll watch for that here, and call on you if you have a question, or if you'd like to drop the question into chat. You can also monitor a question that way. So I see a couple of hands go up right away, and I'll start with just a simple one on my end, Joel. But it's just reflecting your expertise now that, given that you had finished your master's and then you were at MDRU as a research associate around the time of this work, and now you've been in the industry for quite some time. So that kind of experience, I think, is well suited to this question about, what would you maybe do differently today if you were designing a similar or a minerals project that would have value? Would it be different, or any different priorities you might take?
I really think that the approach for the Trek project was pretty ideal. I mean, the multidisciplinary approach, having those fundamental data sets like the continuous mag layer that we don't get any other way than through some system like Geoscience BC, is really a critical base point to work from. And then layering on top of that the geochemical data sets. And I like to think that the integration geological mapping component was helpful as well.
Excellent. Thanks for that, Joel. And I'll turn to a friend and an old colleague, former Vice President of Geoscience BC, Bruce Madu, for the next question. Just need to turn on your microphone. I think Rich in the background can turn on the microphone for you, Bruce.
Yeah, so I've actually put my question through on the chat line, so might be just get you to spin over there if that's possible.
Oh, I see it now. Excellent. Okay. Thanks, Bruce. All right. So here we are. So the question is as follows, Joel. So from your work in the Trek project, integrating geology, geophysics, and geochemistry, are there project outputs that have proven most valuable to industry users in refining exploration targets? So for either Joel or Darcy, are there regions in BC where you believe a new Geoscience BC regional project would benefit explorers and nearby communities? Thanks, Bruce.
Yeah, I think we kind of touched on the first part of that. The geophysical component, being able to provide a consistent look through the till cover is really critical. And the geochemical components, an anomaly is an anomaly. Hard to argue when there's a geochemical anomaly to follow up on that didn't exist before the sampling.
Yeah, absolutely. anomalies are, lead to discoveries, which lead to exploration and development, etc. So that's good. And of course, I mean, this is BC Mining Month 2026, so that's part of why we're doing this webinar today, is to highlight the continuum from geoscience through exploration to development and to mining, of course. So there was a question from Stephen Quinn, but I think we've addressed it. It was about the recording and the presentation being available. So yes, this will all be made available once Joel's had a chance to modify that. I think that one slide I noted, so I'm sure that'll be pretty straightforward on your end. Very good. Looking for other raised hands at this point. Any or geological based questions, happy to address those. I see some geophysicists on the list here as well, so that's always gets attention and interest as well.
While we wait, Gavin, I can also just add a bit of my insight into that second part of the question. I honestly think anywhere would benefit from more geoscience work. Any community would benefit, even places we've been before. But in particular, I think because of the value and what we're noticing as sort of strategic minerals has changed over the years. In areas that could be really beneficial are areas like further east of the Quest project, where we're getting a lot more rare earth exploration along the Wichita sort of trend there, would definitely benefit. And also the coast mountains. We have a lot of glacial recession there. And so we're getting a lot of better exposures in further to the west. So those would be my votes for more public geoscience and data capture.
Excellent. Appreciate that, Darcy. Thank you. And I do see a hand up here from Dave. So if we can turn off your microphone, or you can turn yours on, and we'll let you go.
You bet. You bet. Can you hear? Am I on? Okay, thanks. Yeah, my question is about Eocene extension along the boundaries of the Omanika Belt, or within the Omanika Belt. A lot of for instance, down in the Slocan area, you have a lot of essentially, amagmatic epithermal systems that gave rise to the lead zinc silver systems there. And the heat source is, mid-crustal rocks being exhumed to the surface. And you can follow sort of similar patterns as you go north. So these epithermal systems, of course, they're more difficult to do on a regional magnetic basis. I'm wondering if you can suggest ways that these important systems, because they carry antimony and in some cases tungsten as well, which are critical minerals, is it any sort of techniques that could identify these meso and epithermal systems that are set up by extension?
I mean, I think higher resolution mag would be a useful tool to pin those extensional faults that they're associated with.
Yeah, I would agree. Yeah. But anyway, yeah, just I always like to point out that at least along the Cordillera, from Yukon all the way down to Mexico, you've got other sorts of mineralization that's valuable, that's not directly linked to magmatic sources. I mean, in some cases there's volcanics, for instance, Arizona, but you have these more stockwork-like features that provide a valuable mineral base. Thanks.
Very good. Thanks, Dave. I don't see other hands up, but I do see some comments and questions in the chat. There's one here from Stephen Quinn about revisiting the Toodoggone post the AMARC's Aurora discovery. Perhaps Joel or Darcy want to comment on that.
There is a PhD started right now through MDRU, focused on the Tutagon. Getting feedback from somebody. Yeah, there's a push to get all of the exploration companies working there to provide their magnetic data so we can have a coherent magnetic base map for Charlie to start with, and then later on the fieldwork component of that to get a Tutagon updated geological map out.
Yeah, I definitely second that. I think the Tutagon's a fantastic region, and obviously one that's close to my heart and close to Joel's heart. But I think up there as well, there's a significant amount of exploration being done, every year. So a collaborative approach to that is definitely warranted, I think. And we have a significant amount of data that a lot of these companies have to update what's already exists in the public sphere.
Very good. One other comment we have here from Bev Quist. And Bev, as you know, the ministry had helped do quite a bit of work on Geoscience BC's mine tailings and waste rock project that was published for a year ago now. But thank you for that support, Bev, and the questions about the Earth Science Viewer at Geoscience BC. So we have all the data and the projects and links available, and the Earth Science Viewer is going through basically some upgrading right now. It's currently down, but we'll make sure to get that up at least sooner than later. So with that, look for any last comments or questions. Looking and seeing none right now. I would like to, again, thanks both Joel and Darcy for the excellent presentations. Really reflects the quality of the people we have involved in geoscience in the province. So thank you very much. And I want to also, for everybody else on the call here, put a shout out about another webinar that we'll have in late June, June 22nd, and it'll be energy resources focused. And that'll be led by Dr. Brad Hayes and Dr. Kathy Hickson. So look for that announcement coming soon. So with that, let me turn it to Lana Eagle, Board Chair, for final comments.
Great, thank you, Gavin. And thank you, Joel, and thank you, Darcy, for your presentations. I did learn a lot today, and I think, it's kind of interesting when you think about the geoscience, what lies beneath the Earth's crust and how many millions of years it's taken to form. And then we look at our own lifetime, and sometimes we think they're lengthy, but they're not really when you compare it to the science and what lies beneath the ground. And then how we are able to share that information, the way that the data has been gathered and now formulated, and you're here today talking about that. But we live in a fast changing world, and I think we all know that, and we're all aware of that. And so, Darcy, you brought up how AI is becoming an important part of what you do. And I know I personally am not kind of going that route, but I do have friends that talk about AI and they use AI, and I can see how it's making an impact on the work that they do. So how do we as an organization move forward in this changing world and still continue to share the knowledge of what we've gathered, what lies beneath the Earth's crust, and how that in turn will help, impact the Canadian economy in terms of critical minerals, and how do we do that? And so I think this is where we are as an organization. We've had, as I mentioned at the start, we've had a year to kind of take some time to look at where we are and where we want to go. But we really do need to rely on the help of those that have supported us in the past and are continuing to support us. And by that, I mean, like, if you have any interesting ideas that we could move forward in to sort of change the model, perhaps, of how we do things and help us to become more impactful in today's changing world and how we present that data And as today we heard from some individuals, maybe we should be looking more in certain areas. And I know, Darcy, you used the word collaborative. And I think that's all very important. And it has applied to our history, how we've operated in the past. But we need youthful ideas and minds. And I'm not saying that the old people are discounted, but what I'm saying is that we do have people like Darcy who have come up, and how Geoscience BC helped him evolve his career into what it is today. And there's more of you out there, I know that. So what we want to do, and we kind of, what are the next steps? I think in the coming days you will receive a survey, and in that there will be an opportunity for you to maybe come up with an idea or two that we can utilize that could transform our industry, working towards potentially another webinar or an in-person meeting in Vancouver to help us write our strategic plan and how we might move forward, all towards the end date of our upcoming AGM in September. So the time is short, summer is here, but hopefully you'll have time to think on these things and to be able to answer any questions and help us move forward, because your ideas mean a lot to us. And then we know then that we have heard from people in the industry who really do rely on this information to move projects forward and to find those rare earths, like in Darcy's case, and to certainly critical minerals here in Canada, in BC and Canada. So with that, I'll turn it back to Gavin for his closing remarks. Thank you.
Thank you, Lena. And I'll just say thank you very much for everybody's time and the presentations again. And we'll leave it there. And a reminder, we'll be posting this. It'll be available, and we'll make sure all the links are working. So thank you again, and have a wonderful rest of the day.